Hello everyone, welcome to the session. In this session, we are going to discuss about Programmable Interrupt Controller or PIC. It is also known as Interrupt Controller. The agenda of the session would be what is PIC and its important pins, PIC important registers, priority resolver. Programmable Interrupt Controller or PIC is the hardware component or chip which is used to handle the hardware interrupts raised by the hardware devices. Hardware devices are keyboard, NIC card, video card, mouse, audio card, etc. So these devices first raise an interrupt to the interrupt controller. Then interrupt controller will check and decide if that particular interrupt needs to be forwarded to CPU or processor or not. The microcontroller A259A used as a PIC, Programmable Interrupt Controller. Now let's see the different parts of interrupt controller or PIC. Suppose this is PIC. We will see different important pins of PIC. We have 8 interrupt request pin from IR0 to IR7. So we have 8 interrupt request pins. Then we have one interrupt pin INT. Then we have one interrupt acknowledgement pin INTA. Then we have 8 data pins D0 to D7. 8 data pins. So these are the important pins related to programmable interrupt controller. Now this INT pin is connected to the CPU. This is connected to the INT pin of CPU. Some CPU also name this pin as INTR. So this is connected to this. And the interrupt acknowledgement pin is also connected to CPU. This is how these two pins are connected to CPU. Now these pins IR0 to IR7, 8 pins are connected to the hardware devices like keyboard, NIC card, disk controller, sound card, video card by a device controller. So what I mean is this is your keyboard. I am using KB and it is connected to the controller, keyboard controller. So this keyboard is connected to keyboard controller and then this is connected to this interrupt pin. So in actual, keyboard controller is connected to the interrupt pin or IR interrupt request pin of the PIC. Same for disk. Suppose this is your hard disk and disk is connected to the disk controller DC. Then the disk controller is connected to the PIC. Same for the NIC. Like this is your NIC card. NIC card connected to NIC controller. NIC controller. And then it is connected to the interrupt request pin of PIC. These controllers are the part of the motherboard actually. Now it should be clear how the devices are connected in actual. So when you are pressing key on the keyboard, the signal goes to keyboard controller, then keyboard controller will raise an interrupt to the PIC. Also for your information, if you are interested to know what happens in the backend or background when you press the key on the keyboard. I have explained this in my previous video related to keyboard internal working. So this is the video where you will find what happens when you press the key on the keyboard. It will cover the interrupt controller, keyboard controller, interrupt vector table. So if you are interested, please check this video. I will put the link in the description of the video. Same for the NIC card. So when NIC card receives the signal or data, then it will raise a signal to the controller, NIC controller. Then NIC controller will raise an interrupt to the PIC. So this is how the different devices raise the interrupt to the PIC. And here you have a connection with the CPU. You might be thinking that what if we want to connect more than 8 hardware devices to the PIC? Since there are only 8 pins in 8259A. So how we can connect more than 8 devices? So the solution is, in that case, we use the cascading. In cascading, we connect more than one PIC together or cascades more than one PIC together. Suppose this is the PIC. This is another PIC. So maximum 8 PIC can be connected, can be used in the cascading mode. And 8 PIC together offers maximum 64 pins. So in the cascading mode, we can connect maximum 64 hardware devices. So this is the limitation of the PIC. With the single chip or single PIC, we can connect maximum 8 devices. With multiple PICs in the cascading mode, we can connect maximum 64 devices. Now let's move on further. Now let's see the internal registers related to PIC. Mainly there are 4 registers. So suppose this is your PIC. First is command register. Second is interrupt request register. Third is in service register. Fourth is interrupt mask register. Short form of this register is IMR. This is also known as ISR, interrupt service register, and this is also known as interrupt request register, IRR. These are the internal registers present in the PIC, Programmable Interrupt Controller. Now let's see these registers one by one. First is command register. This is used to store the command sent to the PIC. So suppose this is PIC. Here you have command register. You can say CR. And here you have, as I mentioned, data pins D0 to D7. So this register stored the command sent from outside to the PIC. The commands are like initialization command or end of interrupt command, which is sent by the interrupt handler or interrupt service routine. So these kind of commands are stored in the command register, and these commands are sent to the PIC through data pins D0 to D7. D0 to D7. Let's see interrupt request register. This register stores the status of IRQ pins, interrupt request pins. Suppose this is your PIC. The size of this register is 8 bits. So let's create here 8 bits register. 1, 2, 3, 4, 5, 6, 7 and 8. And here we have IRQ 0 to IRQ 7. These are the interrupt request pins. And here we have one device D0. And here we have controller related to that device. Controller CNT. And this device is connected to controller, controller connected to pin, interrupt request pin. Suppose this controller is connected to IR1 pin. So when device sends the signal to controller, controller will send the interrupt signal on this pin, IR1 pin. Once PIC receives the signal on this pin, it will send corresponding bit in the interrupt request register. So here signal is received on the IR1, so it will set here 1. When PIC will receive the signal on the IR0, it will set this 1 and the rest will have a 0. So if PIC receive the signal on IR7, it will set this bit to 1. So PIC checks this register to see if any interrupt present or not. If PIC finds any bit high or having value 1, then it will proceed further to raise an interrupt to the CPU. So this is the purpose of this register, interrupt request register. Now let's see in service register ISR. So this register specifies or tell which interrupts has been acknowledged by the CPU. So this is the screenshot I have taken from previous slide. This is your interrupt request register. Now let's create here ISR. It is also of 8 bits. This is your ISR IC. In previous slide, we discussed that interrupt request register IRR is used to store the status of interrupt request pin. Now let's also create here interrupt pin INT. And this is INTA. Here is your CPU. And these pins are connected to each other. This acknowledgement pin and interrupt pin. Suppose PIC receives the interrupt on this pin IR1. So the PIC will set 1 here. Then PIC will raise an interrupt on this interrupt pin so that CPU can take care of this. CPU will acknowledge this by this pin. So after PIC receives an acknowledgement from CPU, it set that interrupt in the ISR register, means that interrupt has been acknowledged by the CPU. So it will set here 1. Let's see interrupt mask register IMR. This register is used to ignore particular interrupt, or it specifies which interrupts needs to be ignored. Let's see how. This is the diagram I have taken from previous slide. So let's create here interrupt mask register. It is of 8 bits. Now if particular interrupt is set in this register, then that interrupt would be ignored by the PIC. What I mean is, suppose you are setting 1 here in this register. Even if particular device raises an interrupt on this pin, the PIC will not consider this interrupt. It will ignore this interrupt. If you are setting here 1, then even if the device is raising interrupt on this pin, the PIC will not consider that interrupt. So before considering particular interrupt, PIC check this register. if that interrupt has been masked or not. If interrupt has been masked, then that interrupt would be ignored by the PIC. So this is the use of this interrupt mask register. One thing I also want to highlight is, so we discussed command register, we discussed interrupt request register, we discussed interrupt in service register, we discussed interrupt mask register. So these two registers, IRR and ISR, are used by the PIC only. These two registers cannot be accessed outside the PIC. So these are accessed or used internally by the PIC only. But these registers CR and IMR can be accessed from outside component also, like from interrupt service routine, or we can say interrupt handler. This is about important registers of PIC. Now let's see priority resolver. Priority resolver is the component of PIC which is used to tell which interrupt needs to be taken care next by the PIC. Let's move on to the diagram. So here you can see the connected device. These are the interrupt request pins as I already explained, and this is the interrupt request register, so which stores the status of raised interrupt. Suppose two interrupts has been raised simultaneously. So interrupt 0 and interrupt 1. So here PIC will set here 1 1. Now how PIC will decide which interrupt needs to be taken care first, whether IR0 needs to be taken care first or IR1. Then it takes help of priority resolver. Priority resolver will decide which interrupt needs to be taken care of next based on the priority of the interrupt. So as far as the priority is concerned, IR0 is having the highest priority. So this interrupt would be taken care first, then IR1 interrupt. So the use of priority resolver is to decide which interrupt needs to be taken care next based on the priority of the interrupt. And the pin IR0 is having highest priority and IR7 is having the lowest priority. So that's all for this session. Thanks for watching. See you in the next video.